Hi, this is Robbie Greer. This is my final demo for my research project, which is a terrain editor and a world builder built into my game engine. I'll start by going through all of the tools and how you can use them to build up your terrain and design a game level, and then I'll go behind some of the technical details and the code for how it all works. The first thing you can do is create a new terrain asset. So if you click on the terrain window, then new terrain, you get a pop-up and you have a couple of options, fresh start and height map. The fresh start will give you a completely flat terrain, like so. So there's our terrain, just flat, and you can also create a new terrain from a height map. So I have a file here, create that terrain, and that generates it from a height map. And then you can save the terrain, and that will save our new terrain out to a file. It's called demo, so now when I go to select a terrain, I have my new demo here, and I can switch between my other models and the demo very easily. Okay, to edit the terrain, the engine provides a series of brushes you can use to sculpt, paint, and add foliage. Firstly, for sculpting, is the raise brush. Whenever you select a brush, you get this highlighted area under the mouse, and you can adjust the brush size to change that area, as well as the brush strength to say how much you want the edit to take effect. For raising, it simply raises the terrain underneath where you click. You can also shift click to lower, and you can use that to map out the rough features of the terrain. Next, for flattening, this brush creates a flat area where you paint. You can sample a height by clicking, shift clicking anywhere, and then click, and it will flatten out the terrain towards that target height. Now, sometimes your brushes can create these harsh edges and artifacts, and that's why you have the next brush, which is smoothing. This applies a blur filter over the terrain, which creates a smooth ramp-like structure, and is nice for getting rid of all of those artifacts. Another type of smoothing is softening, which is a little more subtle. It's doing a Gaussian blur. So this will remove the harsh edges, but it maintains more of the original slope, which is just a different effect that you might want. The last sculpting brush is Perlin Noise. This gives you a noise generator down here, which you can randomize and change the properties of to get a different texture. Then when you go to paint that onto the terrain, it's just like all the other brushes. You just paint it on and it applies your noise to the terrain. So with a combination of these different brushes, you can create a lot of complicated effects and smooth them all together to create something interesting. The next type of brush allows you to paint textures onto the surface of the terrain. You can see in this landscape there's already a few textures that have been painted onto different zones. Those textures can be selected here in this menu. So for example, I can swap out this grass with mud or with whatever texture I want, but I'll go back to the grass for now. And then you can paint on these layers using the paintbrush. So the paintbrush has the same interface as the sculpting, where we can adjust the size and strength, except we're going to select a texture that we want to paint with. So I'll select the sandstone and add that here. Select the mud and add that here. And you can paint each of your layers wherever you want. Now, sometimes when you're painting, it creates some harsh edges if you have a really strong brush, like here. So to handle that, we have a blur brush for the texture painting. So what we can do is come in with this blur, and we can convert this hard edge into a smooth transition between the two textures. If you want an even more aggressive blur, there is the smudge brush, which will kind of blend the different textures together to create a very gentle gradient. The last type of brush is for foliage, which is instanced 3D objects that can decorate the terrain, such as vegetation or rocks. When we select the foliage brush here, you can see it has the same interface as the other brushes with the brush size and strength that we can adjust. Down here in the foliage menu, you have different types of objects that you can remove or add new ones. Once you've added them, they get added here to the foliage palette, and you can select which ones you want to paint with. So I'm going to select all of the grass types. Then up here, you can adjust the instance properties. For example, the scale, the variance in scale, how much you want it to be tinted, and how much randomness you want in the color. Then you can set what you want that color to be. I'll select something like that. And then you just go onto the terrain and start painting. I'll increase the strength here, and it spawns some grass objects. Now these are a little too small, so if you want to delete the objects, you just shift click and it will delete them from the terrain instead of spawning them. So I'm going to increase the scale a little bit and then paint again, and then I get some nice grass on the surface. So I'll paint on the grass there, on this hill a little bit, and you can see how it follows the normal of the terrain as well as the height. And if I were to come through with a sculpting brush like this, it actually automatically adjusts its height and position based on what the terrain looks like underneath the foliage. So some other foliage types you can paint on rocks if you want. You can add trees, so I'll select some trees here, and we'll increase that. And you can see the trees are actually configured to always point straight up, because that's kind of what trees do. And you can just paint on an entire forest if you want to, and that adds a whole new dimension to the terrain under the same brush interface as the sculpting and painting. So with our terrain brushes, we created this new natural area of our map, and we can combine that with the other tools in the editor to make interesting little moments in our game world. So for example, I can spawn some objects and just use those to populate this new area. So I'll add a tower here, maybe some other objects, and it all works together to create the overall game world. So I'll have this weird thing here and maybe add a point light to it, and we'll make it glowing red. So by combining the object editing tools with the terrain editing, we can build up a much more compelling game, landscape, and world to explore. So to test out your game level that you've designed, you can very easily jump into the game from the editor by pressing F2. And I've implemented a simple top-down controller here, where I can control this character just by clicking anywhere on the surface, and he will start running towards that position. This shows off the skinned animations that we have in the engine, as well as the lighting on the character and on the surface around him. You can see as I run up this hill, his height is getting perfectly interpolated so that he smoothly moves up the terrain. And this is using the barycentric coordinates to get the exact height at every possible position. And you can see all the foliage in the background, the different textures, and of course the different heights and landscape features. And combined with our objects and our character, it creates a pretty cool game world. Alright, now I'm going to go through the technical side of the world editor and the code for how it works, starting with how you render the terrain. So the terrain obviously looks like a 3D model, but on the right here you can see we also have a 2D image representation of the height field, and this is how it's being rendered. So as I brush onto the terrain, you can see in this dark area, as I raise it, it begins to turn a lighter color on the height map, which then gets reflected as height in the terrain. So going into the code, if we look at the terrain mesh, this is a type of mesh specifically for the terrain. It does a lot of things, but the main thing here is that we store the things we normally have for a mesh, like the vertices and indices, but we also have the texture for the height field. And this gets bound when we go to render the terrain here. We just set that as a shader resource in our vertex shader here, and then in the vertex shader we're going to sample from that height field and set that as the Y position of our output position. So that is how we render the terrain, using sort of this holographic projection of that height field image. The next important component of the terrain system is the quad tree, which is a data structure on the terrain that allows for efficient intersection tests. It has a giant bounding box around the entire terrain, which is broken up into 4 quadrants, and then those are broken up into smaller quadrants all the way down to our smallest node size, which are called the leaf nodes. And then we can test within those leaf nodes where we're colliding with the terrain exactly. And this is extremely important to be able to use our brushes to know where we're clicking and where we should edit the terrain. And it can also be exposed to a game if they want to be able to click on the terrain and do intersection tests like that. So in the code, the tree is composed of nodes. Each node has a rectangular 2D area as well as a minimum and maximum height, which need to be updated as we edit the terrain. And those are stored in a quad tree structure, which has a big list of nodes, and you can create a new tree from a terrain asset, as well as perform a ray cast from the mouse or whatever type of ray you want, as well as some other types of intersection tests. Okay, next for the brush architecture, we have a base class called Compute Shader Brush, which provides mainly this paint function, where you give it the brush size, the center location, and the amount of force to use. This is used for the sculpting, painting, and foliage brushes, and the client code just calls paint. So the first subtype is sculpting, which is defined here, and the key thing here is that the further derivations of this will inject their compute shader into the constructor here, which gets set up as a compute shader. And then when we go to paint, you set the height field as a resource to that compute shader, read-write resource, and then you dispatch the shader based on the center and the radius as parameters, and we actually use the radius to define the rectangular area where the brush is going to be applied, and we dispatch that many threads. So an example subtype is raise, which is the simplest one. It has a compute shader here that it passes into the constructor, and then that compute shader is defined in HLSL. It's really simple. It's going to run over all the pixels in that area, and we say if we're within the radius of the brush, we apply a delta height with a linear fall off, and we just add that into the texture data, which will raise or lower the terrain depending if it's positive or negative. And that is the basics for how a brush works and how it writes to that texture very quickly. So now with our brushes, when we paint on the terrain, we get that immediate visual feedback as the terrain raises. The compute shader writes to the height field texture, and then that gets reflected in the terrain rendering. And if we turn the quad tree on, you can see that the nodes are actually adjusting based on the minimum and maximum height of the vertices that we're painting. And it even updates the parents of the nodes as their children grow or shrink. We can also make edits on a really large scale if we increase the brush size a lot and paint like this. and it's still very responsive and at a high frame rate. But if we turn the quad tree on, you'll actually see there's some delay in updating the nodes, even though we still have a responsive frame rate. And this is because updating all of those quad tree nodes is really expensive. You have to pull the data down from the GPU and then go through your entire quad tree, update the children that changed based on every vertice that changed, as well as all of the parent nodes, which can get really expensive. So the engine introduces some latency here in exchange for the smoothness and responsiveness of the editor, which I'll go into next. So the way we pull down the data from the brush to update things like the quad tree and other data on the CPU is defined here in the brush. We give it a chance to update every frame, and if it has a paint in progress, then it's going to try to map the new height map down from the GPU by calling map, except we're going to use the do not wait flag. This allows us to not have the engine slow down and lose frames because the texture isn't ready to be mapped yet. Instead, we call this every frame, and it only succeeds once it's ready and we can immediately access it. So once we can access the new height field that's been updated, we're basically going to copy it down, and we have an area that's changed. So we define an area on the train called our work area, and then anything we change, we just union that with the existing work area, and that becomes the vertices that we have to do some processing on because they have a different height now. So what we do with that new area is every frame we say, okay, is the total amount of vertices in the area less than 20,000? And while it's greater than that, we just split it in half. So we basically take a subsection of that area to work on once per frame so that we're not doing too much and slowing the editor down. And then once we have the ones we want to work on, we're basically updating the quad tree and updating the vertices in the terrain mesh so that the CPU resources can access that information and so that our quad tree can be accurate. And so this is an elegant trade-off because when you're editing at a small scale, you want to have that precision, and the editor gives it to you. So when you paint in a small area, the quad tree is going to immediately update, and you're going to have that high precision to know exactly where you're clicking. But when you're editing at a very large scale, you're more just clicking in a general area, so it's acceptable to have a little bit of latency on the back end because you don't care as much about the precise location of the mouse on the terrain. So now that we have that brush architecture, you can do the fun part of implementing all the different types of brushes. For example, this is the flatten brush. It takes an additional parameter for the height to flatten to, and then it just interpolates all the pixels towards that height within the brush. The next type is the blur filters, which are defined as this brush convolution. So this holds a matrix that's going to do a blur and sort of average out each pixel based on the pixels around it. And there's helper to produce the average or Gaussian blur here, which gets set as a resource to this shader. And then that gets sampled inside this nested loop to just take the average of all the pixels around the target one and use that to smooth out the surface and create that effect. Next is the noise brush, which defines similarly a matrix, but this is going to be a matrix of a noise texture. You have all these parameters here to generate that texture and some helpers to make different types, and then that gets set to this shader here as a texture for the noise matrix, which gets sampled, and then that changes how the height changes at that particular coordinate to add the noise to the terrain. The next key feature of the engine is the transitions between the textures and having different textures in different zones of our terrain. And this uses a technique called texture splatting, so we can have a smooth transition between the sandstone here in slot 0 and the grass in slot 3 at this particular location. The way this works is in our terrain mesh, we define another matrix or texture that we call our surface layer weights, and this is going to determine how much each texture is weighted at any particular location. And then we also defined the array of actual textures that are associated with each of those weights. When we go to render the terrain, we set the weights as a resource to our pixel shader here, and then we also set the actual textures to their index so that those can be sampled. Then in the pixel shader, when we want to get the average texture for any pixel, we sample what the weights are at that location, and the weights are just a giant texture of float 4s. And so, for example, at this location, it's going to be 1000 because it's all sandstone. Then over here, it's 0001 because it's all grass. And then right here, it might be 0.500.5 because it's a mix between those two. So that gets sampled in the pixel shader. The weight gets, for each texture, we multiply the sample from the texture by the weight, and then we add that to the total average, which is what ends up being rendered on the terrain. And that gives you the smooth transition. And it also lends itself nicely to the painting algorithms, which I'll go over next. For painting to these texture weights, we have a new type of brush called the surface brush. This is pretty similar to sculpting, except the key difference is that the read-write resource that we set is going to be the surface weights matrix instead of the height field, and our shaders are going to edit those weights instead of the heights. So for example, the main one is the paintbrush, which just provides an additional parameter for this vector layer mask, and in the actual shader, it looks like this. It just applies that layer mask to the weight texture so that you can paint on a particular texture. So in the code here, I'll select a paintbrush, select the second channel, and then just click, and now the weights at this location get interpolated towards my target texture, and then that is reflected on the terrain. So going back, we can also implement other types of brushes. For example, the convolution blur, pretty much the same as sculpting, except it's applying that matrix to the surface brushes, allowing us to blur in the textures. Lastly, for the foliage system, our terrain mesh has a subcomponent called terrain foliage, which encapsulates the logic for rendering and managing the foliage. Here, it has a list of graphics objects, which represents all the different types of foliage we want to render. You can add or remove those different types based off of a type description, which just defines the meshes and textures and properties of that foliage type. When we go to render, there's a couple of optimizations that make it a little complicated, but render much faster. So firstly, we ask the quad tree which nodes lie within the camera frustum, and we call those the visible nodes. And then we tell each graphics objects to basically organize its instances based on which nodes are visible. So in the graphics object, rather than referencing a single instance of foliage, it stores all the instances for a particular type, and those instances are organized into buckets in this vector here based on which quad tree node they lie within. So that allows us to quickly only get the ones that are actually visible from those buckets. And then we basically get the visible, filter them out, and then we call render. And render, because we have instances, we're able to call draw index instance, which is much faster, of course, because we have all those different models on the terrain. And that is the architecture for how to quickly render very dense foliage. To add and remove instances from this foliage system, we can define a new brush called our foliage brush, which is going to implement that same paint interface, except this one's a little different because it's adding and removing instances from those graphics objects. So when we paint, we have a bunch of parameters as well as some randomness to basically describe a new instance that's going to fall underneath where we're painting with our brush. And then we add that instance to the graphics object. So the graphics object provides an interface here for adding and removing new instances, and it will place it in the correct bucket, and then it will be rendered accordingly. If we jump into the engine, you can select the foliage brush, and then just paint onto the terrain, spawning the instances underneath the brush location, and then you can delete the instances as well by holding Shift, just like all of the other brushes. Because these brushes have a strong central interface for painting with them and updating them, it's very easy to create a GUI like this one to switch between the different brush types, adjust their parameters, and apply them to the terrain surface. And combining this terrain editing system with the object placement tools, you can create a pretty good looking scene that you can then use in a game and query it from your gameplay code to move around a character and do whatever you want. So that's it for my research project, and thank you for watching.